today. My name is Megan Gorman, and I'm a Customer Engagement Specialist for Test Oil. Before we start the webinar, there are a few things I want to go over. First of all, let me check my audio. If you can hear me, please raise your hand by clicking on the little hand icon in the toolbar on your GoToWebinar application. Oh, wonderful. Thank you. I see some hands being raised. Good. It looks like my audio is working. Wonderful. Now, the other thing I wanted to do is to let you know that everyone will be on mute during today's webinar. This is to ensure a high-quality recording. We are recording this webinar so I can share it with you later on today. If you have any questions, you can submit them by using the questions field in the toolbar on your GoToWebinar application. If we have time at the end of the webinar, we will address your questions. If we do not have time, we will address questions via email. Okay, let's get started. As I mentioned, today's presenter is Terry Harris. Terry Harris is a certified maintenance and reliability professional, certified through the Society of Maintenance and Reliability Professionals. He has worked in the manufacturing process industry for 26 years for a Fortune 100 company. Most of the time was devoted to maintenance area efforts, with most of his career being devoted to improving the reliability of his plant and other U.S. and European locations. Along with working as the facility maintenance and reliability leader, Mr. Harris was involved with many corporate-wide projects to cut costs and improve equipment reliability. For many years, Mr. Harris has devoted his efforts in applying his knowledge to critical pieces of equipment and processes within many industries with excellent results. Mr. Harris has performed training in the U.S., Europe, China, Singapore, Thailand, Canada, and Korea. Thank you for joining us today. Terry, are you there? Terry, are you there? Okay, I see. Terry? Terry, it seems that our audio is not working.
Is any better now?
Wonderful. I can hear you now. You're all set.
Okay, great.
Thank you so much for joining us with today's webinar titled Effective Lubrication Storage and Failure Modes. Thank you again, Terry.
Okay, thank you, and welcome everybody. Appreciate you taking time out of your day for this, but it's a very, very important topic. You know, many of the failure modes that we have in our lubrication processes, you know, start in the way we receive our lubes, the way we store our lubes, and the way the lubes are taken care of before we ever put them into the equipment. You know, I've been in a number of facilities over the last couple of months where, you know, lube drums are stored outside, lube drums are stored in areas that are not controlled by temperature. And so a lot of failure modes occur, and we'll cover some of those as we go through the presentation. But it's a key area, and you'll see how many of these failure modes you can eliminate just with some proper storage. All right, just a little bit about me. Megan was talking about, you know, I worked for Cargill Incorporated for 25 years and was involved in a lot of their reliability programs. You know, I do RCM facilitations around the world. I have my own RCM database, a lot of predictive proactive training. The biggest part of my training over the last 2 years is doing this lubrication excellence training program at plants and getting maintenance people up to speed on the things they do and making sure they do things correctly so we don't add to those failure modes. And then you can see a lot of other things in there. And the bottom one there, which we'll talk about later in the presentation, you know, we started about 4 years ago building portable lube storage and filtration rooms where the unit comes to your site and all you have to do is plug it in. All the filtration and the pumps are there. So we'll look at a few of those at the end as some of the ways to store your lubes. But when you're looking at the ways, or some of the design considerations when you're looking if you're going to build your own lube storage room, you know, and it really, no matter what the manufacturer's lubrication you're looking at the plant, there's still good reasons to filter and store the lubes in a controlled environment. You know, as I do tests on new drums of oil when I do lube audits, you know, I find out that drums of oil have high particle counts. Some of the additive packages are missing. There may be moisture in the drum. And so a lot of people ask why I test the new drums of oil. Well, you find out a lot of failure modes just with the new oils. So we have to filter out those contaminants in order to make our equipment last longer life cycles. But again, as you look around your plant, it's good to be familiar with your plant operation and what kind of contaminants may be present in the lube areas. You know, what forms of foreign material are present. You know, I was at an aluminum recycler just a few months ago, and as we was looking at their lab analysis reports from Insight, we found that, you know, we had a high concentration of aluminum dust, basically, and that was coming from their ambient conditions, you know, not sealing things up and particles in the lube containers. You know, what kind of moisture issues you have at your plant? Are you a food plant where you have wash down issues? Is the equipment exposed to the outside rain and high humidity like along the Gulf Coast? You know, what's the average temperature extremes? I remember the plant I came from, you know, in the lube storage area originally, we could get as high as 110, 115 degrees in that building in the summer, and you could be minus 20 in the winter at times. We had temperature extremes that will cause your drums to pull moisture in. So look at all those conditions at your plant. What are we trying to eliminate at your plant? When I do my failure modes of lubrication training, I talk about the 5 major lubrication failure mode areas. You know, temperature failure modes, how can we control temperature? Moisture failure modes that are in our lubes. Foreign material particles that may be in our lubes. You know, what's the particle counts and what are those particles? You know, viscosity failures. I don't have a lot of instances, but I've got a few instances where drums of oil that were sent to a plant from a manufacturer may have had ISO 220 stamped on the drum, and when I ran the test on the drum, it was ISO 150. And then, of course, what other kind of contaminants besides moisture and particles are present? You know, if you're storing your lubes around areas where they're storing lab chemicals and things like that, is somebody using those same containers that you're using lubes in? Or somebody using, I was at a plant just a few months ago where they had their antifreeze for their mobile equipment stored in the same area. Well, there was antifreeze contamination because they were using the same containers for everything. So some program failures. I just highlighted some few here that go along with lube storage. You know, not having procedures in place for ordering, receiving, storing. I've helped a number of companies write procedures for what happens to the lubricant as soon as it gets to the plant, how it's received, where it's stored, how it gets out of the environmental conditions. You know, not filtering your new lubes as they come in. Here's one that a lot of people don't understand. It's additive package separation. The longer that lubricant is stored, especially engine oils, it's stored, additives do settle to the bottom. So you can get additive package separation in your container or your drum. And this is one of the reasons why, you know, it's a Cargill standard and some standards with some other people that buy lube rooms is we recirc the container once a month for about 10 minutes to remix that additive package. Very important process. Here's some highlight one. No best practice lube storage rooms. No lube consolidation program. I've worked with a number of companies, and one I'm getting ready to go do a project on now where they have over 50 lubricants in the plant. And we're going to try to consolidate that down in the mid-20s. I was at a plant that had 22, and we were able to consolidate their program down to 10. So a lot of the times it's just the additive packages and different things like that, and we can consolidate a lot of those lubes down, but get those down to the minimum number of not only oil-based lubricants, but grease-type lubricants. You know, no filtration training. A number of times I've asked people at the plant, you know, what's the micron rating on the filter on your hydraulic system? Well, they have no idea what that means. They have no idea what the beta rating is. So with this training, they can order the correct filter and remove a lot of these particles and moisture. You know, no moisture reduction program in place to reduce moisture that's getting into their lubes and products. What about foreign material? Well, like I said, new oils are contaminated. Those particles are in there from the process of actually building or designing and building the drum itself to the process the way the manufacturer actually fills the drum. You know, are they using the proper filtration? Are they storing it correctly? So, you know, it's one of these things is improper filtration of new lubes. All new lubes should be filtered. You know, and then the filtration in your process equipment. Even if we put a perfectly clean lube in your process equipment, it's going to gain particles over time. Now, are those particles dust or from the environment, or are they particles of wear from your machines? Well, the lab analysis can tell you that, but we need to filter those particles out so they don't cause wear. You know, there's plants that have no filtration practices. They change oil on a regular basis, but maybe the oil they're putting in there is dirty. Maybe the oil that they're, you know, while it's running is very dirty. You're not using vent filters to keep moisture out. Poor lube storage methods and poor lube equipment storage. You know, you can put your lubes in this perfect condition, But if our maintenance people are running around with vinegar jugs and Tide jugs applying the lubricant and storing those drums out in the rain and in the ambient conditions, we may still be adding particles to our system. Moisture failure modes. Where does moisture come from? Ambient conditions, humidity and rain, and some washdown practices at food plants. Lubrication storage methods, you can gain a lot of moisture. If you have a drum of oil setting in the sun, it heats up. During the day, you get a little bit of rain on top of that drum, and it cools down at night. Even though the drum's never been opened, you'll pull moisture in through those bung fittings. You know, what kind of equipment are you storing your oils in? We can gain moisture in those areas. So many of the failure modes in our plants start with our lube products being received and stored properly. Moisture, FM, contaminants are in and around the lube containers and the lube equipment. And remember always that new lubes are not clean. There was a plant in Texas where they were storing the drums outside, you know, until they got their lube room built. We at least put some covers on the drums because they had water on top. You can see some of the drums are rusty. Some of the drums have been there a very, very long time. We had to dispose of them because going through the cycle of being in the sun and heating up, the contaminant or the additive packages were completely gone. This looks like a good storage system. This was at a power plant, but these tanks had been in there about 25 years. There was sediment in the bottom. They were filled from the floor upstairs where they dumped drums into a big like sink and just opened valves to get them down in these containers. Even in the sight glass they looked good, but there was a lot of sludge, a lot of crud, and of course they were steel tanks in an unambient controlled room, so we surely had some rust in there. So in the oil analysis on a couple of these tanks, we had moisture, had high particle counts, and a lot of issues there that were causing wear for their equipment. This looks like a normal lube storage room. This one's a little cleaner than most of them I take pictures of, but here again, you know, there's no desiccant breathers on the drums. The room was in an area where it goes through all the ambient changes, no heating, no air conditioning here, no filtration on the drum coming out. So again, a lot of improvements can be made in this lube room. Here's one here where the drums are stored right out in the plant. You can see open containers that they're using for oil. They're stored there. You can see drum pumps, funnels, you know, all kinds of bad practices here that are going to cause moisture and contamination in your lube area. This is one in another facility where they're storing the lubes in an area where they're storing diatomaceous earth, silicone, and all kinds of filter aid products. You can see the filter aid and particles on top of the drums. You see the yellow containers that are sitting on top of the drum. One of them has oil in it in the middle. Well, this is what that looked like when I poured the oil out. This is what was on the top of the drum, on the top of the container, and down in the container. Now, I watched maintenance people that over the weeks I was there go to a drum, fill this container up with oil, and take it out and dump it in a hydraulic unit or a gearbox. So again, these particles here cause major, major damage to your equipment components. We wiped off the top. This was a different one that was there, but look at the number of particles, metal shavings, and this, like I said, this was in the maintenance shop. There was welding going on, there was cutting going on and grinding. All these particles that they weren't cleaning out by not using proper containers like from Oil Safe are in this lube and are going to cause major equipment component damage. This looks like a clean area here. You know, there's a drum of oil. This is for an expeller. This was at a plant in Canada. The expeller gearbox that the maintenance people topped off this gearbox probably daily was about a $400,000 gearbox. And you can see this funnel sitting there is covered with dirt, dust particles, not only on the outside but on the inside. And as I watched them do this over the course of 2 weeks, they, without a doubt, would go over there and just dump the oil right into the gearbox. Again, high particle counts, very, very highly critical gearboxes, very expensive gearboxes, but again, causing them to wear out about half as fast or twice as fast as they should. I put this picture in as this precision lubrication storage. You know, they got new oils in here, they've got used oils in here, they've got mop buckets, and they've got a shower curtain to keep the contaminants out. Probably not a good storage area, and a lot of improvements can be made here. So again, why do we need effective lube storage? You know, our lube products need to be protected from the environment, the plant dirt, the FM, the moisture, the sunlight. We need to filter our new lubes or lubes as you use them. You know, a lot of my customers will just, and I'll show you a picture later on, they just store the drums, and we have a little recycle device we can buy from Desk Case that will actually pull the lube out of the drum, recirculate through a filter, and put it back in the drum. So we do a couple things with that. We filter the lubricant while it's in the drum, and then we also mix up the additive package that could have settled to the bottom. And then there's also a spigot on there where they can take clean oil right out of the drum into their container. You know, storage of your lube application equipment, your containers, your funnels, your grease guns and filters, these should all be stored in clean areas. You know, we're trying to eliminate particles. Keeping your lubes separate from other plant chemicals. I can't tell you the number of plants I've been in where you go in the lube storage area and there's lab chemicals, there's all kinds of other things in there that shouldn't be in there and they're not properly labeled. You know, there was a major failure at my plant about when I was there where one of my maintenance people put the wrong lube in an Alpha Laval centrifuge. And the lube had a 25 on it from Alpha Laval, and the ammonia compressor oil for that plant also had a 25 on it. Well, you can imagine what happened 24 hours later when the gears failed, and that was a major downtime just by not having things properly labeled. So labeling is very important. Products stored in a controlled temperature. You know, one of the reasons that people tell you to store your grease guns on their side or on their ends is because if they warm up above 104 degrees, the oil will actually start separating and leaking out. And of course, if you're storing them at a higher temperature, they will oxidize a lot faster. You want a product stored in controlled humidity conditions so there's not moisture being able to get into our lubes. We want our products labeled and visible so it's easy to see. Now, the ISO codes for the different colors of lubes, as we're building more and more lube rooms, excuse me, this is becoming more and more popular to color code not only the lube container, but the lube equipment. It's a clean area to fill the lube equipment. You know, a lot of times I go into plants. I was at a Jimson plant where the maintenance guys were filling the lubes with massive amounts of dust in the air, filling their containers up in the lube storage area. And of course, that dust was going right into their containers. You know, we can recirculate our lubricants to mix additives and refilter them. And it's a better inventory control method. You know, using the oldest lubes first. I was at a plant in Texas where I crawled across the top of a bunch of drums stored in the lube area, and there was a drum that was 10 years old in the back of that storage area that had never been used. Of course, the supervisor asked me what he should do with it, and my answer was you have to dispose of it. There's moisture, the additive package is gone, and it's going to add no value as a lubricant in your critical equipment. So again, we have to move from storage areas like this where we have lots of dust, lots of contaminants, and we need to move into areas where we can eliminate the dust and the dirt and the things that are around there. Now this develops writing some written procedures. You know, if anybody needs help, I've got a couple of those that I've written for companies that probably don't care if I share those with you, just what your written policy should be for receiving, storing, and taking care of your lubes. So it's a must for any plant that's moving into lubrication excellence. If you've even thought about it, or this is something that your plant's looking at, this is the first step. So remember, I'll repeat that again, your new lubes are not clean. They're clean to some standard. I think if you check with Insight and you look on their reference samples, you'll see most of the lubes are 18, 16, 15 probably as an average. And that's normally what I find in brand new drums of oil, but as those drums of oil sit around and as they go into different equipment, you'll see those ISO counts go up in the 20s. Now, I like to take new lubes and filter them down to 16, 15, 12 if I can, or that or better. And that's we try to put the filters on our lube rooms to do that. Our lubes must be clean and dry. You know, you'd be surprised how many lubes I test when you go down to the bottom of the barrel, the bottom of the drum when you pull your sample and see how much moisture or other contaminants are in the bottom. You know, controlling the environment that your lubes are stored in. You know, I talk to plant managers about this. They look at you like you're crazy that you need to have your lubes stored in a air-conditioned room or a heated room. But it's actually true. If you want those lubes to last a long time, we need to store them correctly. This is a slide from Caterpillar. Caterpillar sales people or Caterpillar's mechanics go out in the field. You know, the reason Caterpillar equipment lasts a lot longer than many people's other manufacturers of equipment is they filter the oils in their transmissions and hydraulic oils down to very, very low levels. So this is an illustration of a human hair. These are the particles we're trying to get out. That big particle there is probably a 40 microns. The diameter of a human hair is about 70 or 80 microns. So you can see the particles that are causing us the most trouble are not particles we can even see with the human eye. The human eye can only see a particle that's larger than 40 microns. You know, we need to reduce our particle. We need to get those particles out that we can't see. This is a slide here when I was doing training at my plant for my maintenance people years ago. The sample on the right, I had a maintenance person go up and pull a sample out of a gearbox. The oil had been changed about 2 months previously. I had him bring it into the shop in a glass sample jar. I had every one of my maintenance people look at it, and I asked the question, should we change the oil? and the oil looked great. It was a golden color. I couldn't see anything in it. They couldn't see anything in it, and they all said, no, there's nothing wrong with that oil. When I sent it to the lab, this is the picture that came back. It was a 22-19-17. All these particles in there, fly ash, coal dust, some metal particles, a little piece of brass or bronze there. We went up there and filtered that gearbox with a 10-micron beta 200 filter. The lubricant came back from the lab as a 17-14-12. This is what it looked like under the 100-power microscope. Now, all I had to do was ask them the question, how much longer will the gearbox last if we keep the oil like it is on the right rather than like it is on the left? And the answer, this is going to be the same for all your equipment, whether it's a hydraulic system, whether it's an engine, whether it's a gearbox, they're going to last 5 or 6 to 8 times longer. And I've seen particle counts. I was at a plant in Alabama where we pulled oil samples out of all the hydraulic units. They had nothing in the plant cleaner than a 23, 22, 21. So after they did the training, they did a lot of filtration. We built a loop storage room there, and they're going to get a lot longer life out of their equipment. You know, for that plant, probably 8 to 10 times more life. This is just a typical hydraulic system. If we take a ISO code on the side there, a dirty ISO code, let's look at the 22-19-17. And we filter that oil down. If we go to the top bar, filter it down to a 16-13-11, which is about 10 micron beta 1000, you're going to get around 5 times more life. And as we start filtering that oil down to these lower levels, you can see if we went down to a 3 micron beta 1000, you're looking at 10 times the life. So that's a typical hydraulic system, and I know it works. We accomplished it at the plant that I came from, and we're accomplishing it at a lot of facilities around the U.S. and around the world. Moisture failure modes. If we look at the left-hand column here, we see 1,000 parts per million of moisture. If we can reduce that 1,000 parts down to 50 parts per million, look at, if you follow that bar up to the top bar, that's 6 times the life just reducing moisture. So you can see the effects of particles and the effects of moisture have a huge effect on the life of your equipment. So both these things we have to figure out how to keep out and how to control in our plant equipment. Here's a bearing life extension chart. Again, I'll show one more of these where we see the 22-19-17 on bearings, and we follow that line across to the 16-13-12, your beta 1000, 10 micron, and you can see that's around 3 times the life. And then as we clean that oil up, the life gets better. So lubrication storage fundamentals, again, develop those written procedures to get how to get the product stored, how do you get them filtered. Develop some filtration standards for moisture and for material. Now, one of the things, you know, if you're not careful, you don't want to start filtering down to very low ISO codes right away. Pick a contamination level. You know, if you find a lot of your equipment's above 20, you know, try to get that filtration level down to about an 18, 16, 15, at least back to new in your equipment. And then as you get your program developed, start using better filters and better procedures. You know, design an area away from foreign material, moisture, contamination, and make sure that room is ambient controlled. It's very important for the life of your loops. Store lube equipment in the area to keep the particles off your lubes. I remember my guys got so into this when they came in at the end of the day, they would put their grease guns into a plastic Ziploc bag and put them in a cabinet. So we were trying to control all the particles that were in our equipment. Here's an internal storage building. This was installed inside of a warehouse, and you can see they just built an insulated building in here. And this is what it looked like on the inside. It was air conditioned, it was heated. All their lubes, all their lube equipment was kept in this controlled, clean area. You can see the tanks there have desiccant breathers on them. They have spill control. They have shells for their grease, their oil-safe containers. But again, a very, very nice room. I know these guys, this was done in 2005. It probably still looks that way today. Very, very conscientious group. This is one of the mine in northern Nevada. And we just cut some doors. When I got there, these big containers were just stored under a lean-to. There was water and dust. And so we just took a 40-foot shipping container. We put some roll-up doors in it. We got the stuff out of the weather, got some heat in there. It wasn't air conditioning, which they should have probably done that later, but this was a lot better than what they had when I got there. All the lubes from those containers you saw on the side were pumped to these hose reels, plus some drums here. Then the mine trucks would just come up here and get their lubricants right out of these hose reels. So they were getting filtered lubricant into the mine equipment or the mobile equipment instead of just pumping dirty lube in. Now, before I got there, when we checked those totes, we checked what was actually going into the mine trucks. They were up in the high 20s on their ISO codes. So lots of failures, lots of wear on the mining equipment. Here's a lube storage room that a customer put in the all steel tanks. The only problem with this one was everything was pumped through one pump, so it had some cross contamination there, but again, much better than the system he had in before. This is some bulk storage at a facility. The reason I kept this slide in there, we know one of their big issues here where there was a lot of moisture in the oil, and so we put desk case breathers on top of these tanks. I came back 6 months later, and the breathers had went from blue to red to white. So I basically told them, if you're not going to change the breather, you might as well just put the vents back on top to atmosphere. But again, this is our efforts here. We're trying to eliminate moisture. Another lube storage area, building a chemical area of the plant. But again, you know, lube's in a clean containers, in a spill-controlled area. And again, they're trying to make an effort to keep their lubes in an area where they're not going to get contamination. Here's a picture of a storage cabinet. This is in one of the lube rooms we sold a customer. You know, they got their oil-safe containers. They got a cabinet in there. They got some plastic storage containers to store all their lubes. And this room here is actually in an ambient control room also. Here's a 40-foot shipping container. We built this for a customer in St. Louis, or outside of St. Louis, but they had 10 different lubricants there. Every lubricant came into the room. There was 10 different pumps. Each of them had dual 10-micron beta 1000 filters on there, and it pumped the oil into the 10 tanks you see at the far end of the room. Desiccant breathers. Each pump would have a lance. They had stored drums right underneath the pumps. But you can see a very, very nice storage room. The room was air-conditioned. The room was heated. And there was only just certain individuals allowed in the room to maintain this room. This one here had some spill control. You can actually, in these 40s, make the whole bottom floor spill control if you want more capacity. But you can see a nice storage room. And again, all they have to do is hook up the power when it arrives at the plant. Here's some of the options, you know, storage benches and cabinets and things like that you can use in the room. This is a company that uses all steel tanks, all steel piping. They have a steel floor. Again, for their conception of fire control was to keep everything in steel. But as I'll explain later, lubricants aren't very susceptible to catching on fire, so we'll discuss that on the last slide. But here you can see another effort, an ambient controlled room, you know, to control the where the lubes are stored. Very nice setup. Here's a unit that was stored at a Coke plant in the U.S. here. You can see here again that you can set these anywhere you want. You can put them on gravel, you can put them on concrete, you can put them on spill control. A nice, easy way, and I can show you if you guys want to do your own. Let me know, and I'll tell you how to put all the stuff in it. This one here was unique. This is in a salt mine that's about 1,800 feet under Lake Erie and about 3.5, 4 miles out under Lake Erie. The company has a lot of mining equipment down there, and so they bring all the lubes in through the little air pumps on the side, filter them into these containers, and then on the wall the lubes are pumped from the containers to the hose reels. So nobody's allowed in this room but one person. And then as they go in, as the mine trucks pull up, this is what's on the outside. They have all the loops with some nozzles. They have grease and air there, so the mine trucks pull up here, get whatever lube they need in their equipment, or they have a kidney lube pump on there. They can actually bring a hydraulic unit up there and kidney loop it through one of the filters if they want to. But again, these are all customer specified design units for what the customer needs. Again, your lube equipment, you know, getting your guys trained and in the habit of storing the oil-safe containers, storing your grease guns, storing your greases in a controlled environment. You know, if you can, it can be ambient control, but at least get them out of the particles and the dust. This is a small lube room at a JM Smucker plant. There's a food plant. Everything's white, but a nice little lube room setup. And again, you can see on the outside here, they transferred all the lubes in. They never really put lubes inside the room. They set the drums outside and then transferred from the outside into the room. So again, a nice setup outside of a maintenance shop in Memphis, Tennessee. Here's the inside. You can see here, you know, smaller tanks at this facility, all 35-gallon tanks with breathers. They have a drip pan underneath there to catch any drops that come out of the spigots on there. There's all spring-loaded valves on the bottom. But again, you can see there just a lot of options you can use, and you need to think about some of these as you're designing your room. You know, the drawings, there's all kinds of drawings, any kind of layout you want. This particular one here has an office for the lubrication technician built on the end of a 40-foot lube container. And this one here was actually shipped with all the pumps, the office equipment, everything in place. When they got it there, they hooked the power up, and they were using it on day 2. So Again, lots of options. You can see here they got drum storage in the room with their roll-up door. And then plus being able to filter all the lubes and get all the lubes into their containers. So again, this one here, I wanted to show you this one. A lot of concerns nowadays over maintenance people handling drums. This is a trolley system we build, so you can actually pick the drum up outside the room. You can move it into the room, set it anywhere you want it. Now this unit here, if you look in the background, happens to be Class 2 Division 2 explosion proof for coal dust. So that's another option. But here they didn't want their guys handling drums, so they can take the drums into the room, and really it's an all-access drum trolley built inside of a 20 or 40-foot container. Now this is the system here I told you about earlier. That's in the room with the trolley, and all they do is bring drums in. You see this device down at the bottom leaning against the wall. You can buy those from Deskcase, and you can also buy them from me. I'm a Deskcase distributor. But you screw this into the 2-inch bung hole in your drum. You hook the hose up to it. You pull the oil out of the drum. You run it through the pump and the filter. This one here's got an air pump on it, and then you recirculate right back in the drum. So you can recirculate the drum and pull out all the particles. You can mix up your additive packages, and then you see the little beer tap spigot valve. This is where, while the drum's circulating, a maintenance person can come in and fill up his container right there out of the drum. So everything's coming out of the drum is filtered. And if you filter that into an oil-safe container, that means he's got clean oil actually in that container where he's going out and putting it in your equipment. So again, it starts lowering those ISO counts because you're now actually adding clean oil to your equipment. So again, a lot of different options, a lot of different things you can do here to improve your lube program. So you actually don't need to buy big plastic tanks and things like that if you use the method this company used. And again, but this is stored inside of an ambient controlled room, the drums are. So some design considerations, and I'll just go through some steps here. But again, the first thing you want to look at it, can I consolidate my lubes down to some manageable level? Can I get all the lubes into 1 or 2 locations? Some of your bigger facilities, I'm working with a big company now, and they're going to have 5 lube rooms in different locations around a mine because they can't consolidate everything down to 1 location. Determine any contamination issues with your current storage methods. Where are the contaminants coming from? Is it the way I'm storing it, the way I'm receiving it? And again, this is another step here. Determine the size of the containers. You have to know what your monthly or annual usage is. Some of your containers may be as low as 35 gallons. Other of your containers may be as much as 300 gallons you want to store. So determine those storage container sizes. Determine the storage container material. Now, I prefer plastic storage containers. The material's a lot cleaner. You don't have to worry about rust. There's a lot of people that still order steel tanks. As long as you got those steel tanks in an ambient controlled room, you're fine. But if you put those tanks in an area where it's going to heat up and cool down and there's a chance to get moisture in there, you could develop rust over the years. We also sell aluminum tanks, which work very well, especially in corrosive areas. Determine your ambient control needs. If you're in San Diego, California, the temperature extremes are not very much there, so you may not need any air conditioner, heat, or not even a dehumidifier. But if you're on the Texas coast, you may not need heat, but you're going to need an air conditioner, and you're probably going to need a dehumidifier in that room. Determine your fire safety controls if needed. That a lot of times is determined by your FM Global insurance guy or your company policies. But again, do you want water fire protection? Do you want dry chemical? All those options you have to look at. What do you need for auxiliary storage cabinets? Store your equipment and your grease guns and your containers and your actual grease tubes. And then you've got to determine the type of pumps. Do you want electric pumps? Do you want pneumatic pumps? All those things are available and different options on those. And then what filtration level are you going to try to go to first? Do you want to start out at 10 microns beta 1000? Do you want to jump right into 3 micron to get all the particles out? That's other decisions you have to consider when you're designing your room. Spill control. And what's the spill control method going to be? There's not many facilities that are going to be built at any plant without having this item covered. So, do you want to spill pans underneath the containers? Does the whole floor, does the whole room need to have spill control? What's the access to the lube storage area? Is it, in an area where everybody can get to it? Then, of course, there's a lot of accessories. The hose reels, like the couple companies put hose reels on so they don't have maintenance people in the lube room. There's all kinds of options for paint, vinyl siding, different things like that. What are you going to build the room out of? And then, of course, reemphasize material storage safety issues. Remember that lubricants do not put off vapors. If you look at the vapor flash point of lubricants, I think the lowest one I've seen in years is 465 degrees F, and they go up to around 525 or 550. So a lot of people will ask me, tell me they want explosion proof since it's an enclosed room storing lubes, and you really don't need that. I sell a lot of them. I don't mind building them, but it's something you pay a hefty price for. Here's what lubricants are. Lubricants are Class 3B fluids. They have a vapor flash point above 200 degrees F. So that's what a Class 3B fluid is, but lubricants have flash points from 465 to 525. They're very hard to get burning and keep burning without a sustained fuel source. And I used to demonstrate this with my maintenance crew and some others. If you take just a 5-gallon metal bucket, you put a gallon or two of lubricant in the bottom of it, you're taking an acetylene torch, you put it down on the lubricant. After a while, you can get it to burn. But as soon as you take the torch away, the fire goes out. Now, if you heat the lubricant, if you heat the outside of that bucket to a high temperature with the torch, and then you run the torch across the top of it, you can get a flame and you can get a flash. But again, in most cases, you need to look at this when you're looking at what you're going to design your fire protection system. The majority of my customers I put a water sprinkler line in every unit, or we have water sprinkler heads in the units we built at plants, but that water there is just to put out small fires that may start in the room. You know, other customers don't have access to water, so you can put a dry chemical tank in the room with some nozzles in there that put off nitrogen and dry chemical if you would have a small fire. But again, I get calls all the time from fire marshals even that says, well, you know, you got oil stored in this room and you need to have foam because that'll never put out a fire if the lube containers catch on fire. Well, I can tell you now, if you catch a couple 80-gallon lube containers on fire, there's not much you can do with it. So what you're trying to do with your fire protection is control any small fires, like from some smoldering rags or some other reason that they would catch on fire. But keeping these lube rooms clean and free of vapors, I know, is one of the things I tell people. Your fire protection can be minimal then. All right, so I'm hoping that helped everybody in looking at considerations for designing their lube storage. I'm hoping that gives you some ideas, but again, there's a lot of failure modes, as you can see, in storing lube, receiving lube that we can eliminate, and your equipment's going to start lasting much, much longer.
Wonderful. Thank you so much again, Terry. We do have a few questions,
Okay.
but it looks like they're very complex. Maybe this one you'll be able to quickly answer. Let's take a stab at it. What do you say, Terry? Is that okay?
Sure. Sure. Let's go for it.
Okay, let's see. At what filtration level do you start filtering out the additive packages?
Well, the additives, many of the additives are soluble, but if you get into like zinc that's in hydraulic oils, that could be a particle. But I've been told that the particles are usually never no larger than 3 microns. So I always tell my customers in industrial situations I wouldn't filter below 3 microns. I have a couple customers that filter down to 1 micron, but I think for most industry use that's probably too low. Because in my training, I tell that the average film thickness of a loaded bearing or a loaded gear is 5 microns. So if we get the particles out less than 5 microns, you're going to have very, very little, if anywhere, from particles.
Wonderful, wonderful. Thanks for that quick question, Terry. And again, thank you all for attending the webinar today. In just a few hours, you will receive an email with a survey and a link to the recording of today's webinar. Thank you again, and have a great day.
Thanks, everybody.